morning everyone. Today we are going to discussing about the another important topic on computer network, which is method of framing. So in this session we are going discussing about this what is framing and how many types of framings are there, how we are analyzing the framing mechanism and how much it is important on the when evaluating the error control and flow control mechanism in computer network. So in the methods of framing, we have four methods are there. So basically, while we construction any kind of frames, so in the framing structure, when you see any kind of framing structure, the information is coming from packet to the framing structure. So what kind of frames we are using that one, and how we design the framings. So all these things we are going discussing in this session. So in the first one is method of framing. So in the method of framing, basically we can able to evaluate to control the error control mechanism as well as in the flow control mechanism. So in the method of framing, first one is the character count value. Second one is flag byte value with a character stuffing value, which also calling as a flag stuffing value. And the third one is we calling as a starting and ending flag, which we calling as a bit stuffing value. And the another important thing we calling as a encode violation. So we'll go for this physical violation, physical encoding mechanism, how it is shows impact on that one. We're going to discuss in this sessions. So what is character count and what is mean by this bit stuffing value and what is mean by this flag stuffing value and what is mean by this bit stuffing value and what is mean by this physical encoding violation, we are going discussing in this session. So while the information is transmitting from source to destination, so how much amount of frames are transmitted in the character section, how much amount of frames in the information transmitted from source to destination. So first we are able to analyzing about this, what kind of framings we are using that one and what kind of bits we are using that one. So we have to calculate the counter part of that one. We have to calculate the how many characters count as well as how many frames are we transmitted. For example, each and every frame which contain how many frames are there, how many packets are there, how many characters are there. All these things we need to calculate while the information is transmitting from source to destination. For example, when you see this one, this structure, this we calling as a my frame 1 structure. So in the frame 1 structure, so here when you see how many frames are there, for example in the frame 1 we having as a 5 bits are there, for number 5, 1, 2, 3 and 4. So and similarly in the frame 2 we having as a another different frame sequence is there, and similarly frame 3 and frame 4. When you see frame 1 contains 5 characters, frame 2 contains 5 characters, but frame 3 contains 8 characters and frame 4 contains 5 characters. So here while information is transmitting from source to destination, how many information is transmitted, how many frames and how many characters are transmitted, we are going to give information to the resource section. Based upon that one, in the resource section we are able to sync up with the frame 1 character, frame 2 character, frame 3 as well as the frame 4 character values only. When you see this one, so here the frame 1 is started ending with frame packet 4, the character count number 4, and similarly here the number 9, and start next sequence should be started at 8 values only. So here we need to calculate the values. So which means the same information is transmitted from source to destination, accurately receiving the information in the resource section, which means there is no error. We calling as a without error values only. But due to some issues, maybe the flow control issue, maybe error control issue, while evaluating the information is transmitting from source to destination, if any frames are getting damaged, so instead of this one, because here the information, when you see this one, frame 2 contains 5 characters, but when you see this one here, the frame 2 is started 7, but the frame 2 started 5th point only, here started 7th. So this should be the frame 2 mismatch of my information on the transmit section. So that should be sync up error is there, that we calling as a one error, we calling as a one error values only, we calling as single bit error. What is single bit error? Single bit error is nothing but while information is transmitting from source to destination, only one bit error should be occur, that we calling as a one bit error, we calling as a single bit error. And second one is we are going discussing about this character stuffing, also we calling as a byte stuffing. So what is byte stuffing? So when you see this one, any kind of information in the section values only, any kind of information in the information transmitting from source to destination, right? Here we having as a header files is there, payload information is there, apparently we calling as our data information, and second one we calling as a trailer values. But before this information and after my framing structure, we are inserting one kind of thing we calling as a flag. The flag either may be a 0 value or maybe a 1 value, but most of the reality purpose we are using 0 value, because while the information is transmitting the binary formation which is 0 and 1, so most of the cases flag, which means 0 0 in the sense there is no meaning of values only, which is a countless value. So the flag values must be using the 0 values only. So while inserting the framing structure, what is the framing structure here? Header files, payload files and trailer files. So before the framing structure, I am able to inserting one kind of field values only, which is flag values only. Flag in the sense we are inserting a 0 is a another bit values only. We'll see this one. For example, A is a bit is there, flag is there, as well as B is there. So while information is transmitted here, we are going to inserting up one kind of button. We calling as a escape button. So similarly here, so when you see this one, the figure A, which is a delimited flag values only, flag byte values only. But while we go for this second one in the B sequence, we are going to inserting about this another kind of structure values, another kind of escape kind of things values only. We are going to inserting, we are going to stuffing the another value in our information, that we calling as a byte stuffing values only. And similarly, we calling as a byte stuffing and unstuffing values only. Well, you see this one previously in this structure. When you see this one here, we having as a is there, escape is there, and similarly flag is there, as well as my B bit is there. So while coming to this one, so here the flag value is there, that is coming from upper layer, which is from either should be a network layer or from the transport layer. That is comes to the upper layer to the data link layer. Here the flag is there, the flag structure is there, as well as escape is there. So here the frame information is transmitted. What is information we transmitted? We are going to transmit information. The flag value is there, as well as escape value is there. So the information is transmitting. So here we are going to inserting about this n number of bits over here. So how the information is transmitted, we are going discussing here. At the same time, we are going to unstuffing mechanism as well. For example, I need to transmit information 1010. So this is my payload information. So before this one, I need to insert the header files as well as the trailer files. After this one also, I need to insert this one kind of information, which is the flag information. So that we calling as the bit stuffing values one. So same way in the unstuffing mechanism, while in the receiving section, we are going to unstuffing of this flag values only. So in the resource section, we are able to remove this value and will be synchronous with decoding this only by original bit information values only. So that we calling as a unstuffing values only. So here when you see this one, this frame is we are going to transmit information from source to destination, which is flag, header, escape and flag. So this is the information we transmitted. This is the first section value and this is the second section value. This is the header file section value and this is the transmitter file section, trailer file section value. So here this information we transmitted, but here we need to add 2 extra bits values only. In the resource section, we are going to add 2 extra bit section values only, but down the layer we are able to unstuffing this value and we decoding the exact payload mechanism values in actual information values only. And third one is bit stuffing values only. So what is mean by this bit stuffing? Previously we discussing about this flag stuffing. What is flag stuffing? Before and after we are inserting this flag values only. But here in the bit stuffing mechanism, so every 5 consecutive ones we are going to insert in one kind of information, that is 0 information, that we calling as a bit stuffing. For example, when you see this one, this is my data coming from original layer. So we having as a huge amount of information is there. So sequence of n number of ones are there. For example, 1, 2, 3, 4, 5, 6, 7. 7 consecutive ones are there. But after 5 consecutive ones, we are going to insert in this one kind of 0 value. So that we calling as a bit stuffing values only. What is meant by this bit stuffing? While information is transmitting, well, 5 consecutive ones are there. So after 5 consecutive ones, we are going to inserting a new bit that we having a 0 bit value between the session values and between the information values only, that we calling as a bit stuffing values only. So the flag stuffing is different as well as bit stuffing is different. What is flag stuffing? After and before and ending the value, before the value and after my information ending value, we are going inserting about this flag value, that we calling as a flag stuffing. But this this bit stuffing between the value, between the information session, we are going to inserting about the information. After 5 consecutive ones, we are going to insert the information which is 0 value, that we calling as a bit stuffing values only. And similarly, when go further in the down the layer, we are unstuffing and we decode the information in the receiver section. And the another important thing is physical layer coding violation. So when encoding, the violation method is when generally information is transmitted from source to destination. So here we are going for this encoding section as well as in the decoding section, the receiver section. So while in the network architecture, how much amount of information we're transmitting, we are encoding that information on the physical medium, which means we need to follow some redundancy mechanism, we need to follow the cyclic conductance mechanism. All these things we need to follow for that one to transmit the information from source to destination. Because when the information is transmitted continuously, for example, when n number of information is when number of frames are transmitted continuously, assume that one, the frame 1 to frame n are there. So these frames are continuously transmitted from source to destination. So based upon the we didn't follow the redundancy mechanism, the accuracy mechanism, it may get chance to signal damage or may loss of some kind of frames values only. So in the receiver section, we are unable to decoding the information. So while we go for this information transmitting, we need to follow the structural mechanism while encoding the mechanism, that is a physical medium mechanism, which means it includes some part of the redundancy value, accuracy value. We need to follow that one, which means while we using more than one information, one graphical structure is there, we simply encode the value and we represent the one variable data value. So based upon this information in the resource section, we easily decode the value, so without information is damaged. So this we calling as a framing mechanism. So in this session, we are discussing about this, the framing value, which means what kind of framings we are using that one. So in the framing structure, we have 4 types are there. Based upon this character count value, how much amount of characters we are count that one, based upon my framing structure value. And second one is bit stuffing value or as the flag stuffing value. And the last one is we calling as a physical coding violation. So everything is different from other structure. But for example, in the character coding structure, we are just count the values of how many characters present in a frame. For example, when the information transmit, 10 different frames are generated. So the frame 1 may contains 4 characters, frame 2 may contains 2 characters, frame 3 may contains 8 characters. Depend upon my framing structure values only, we are going to generate the count values only. Same amount of information we transmit in the resource section. In the resource section, we based upon the character count value, we decode the information, that we calling as a character count. But while see this one, the flag stuffing and bit stuffing, these are bit similar values only. But the flag stuffing is after my information, for example 1010, here I need to add the 0 values. After my information is started and ending of my information started this 0 value, that we calling as a flag. So this amount of frame may be a 8-bit length, 4-bit length or 16-bit length, we doesn't bother about that one. But in the bit stuffing value, so here also the frame length, we doesn't bother about the frame length value. But after 5 consecutive ones, we are going to inserting about this 1 0 value, that is a must and mandatory one. So that we calling as a bit stuffing value. Here we are inserting information before the value and after the value, that we calling as a flag. Here between the information, that we calling as a bit stuffing. And the physical coding, which means we are able to analyzing about the information in the encoding section, because we need to follow the accuracy and redundancy mechanism of my information transmission section, that we calling as a physical coding values only. So in the next topic, we are going discussing about this error control mechanism, which means how these frames are helpful to control the mechanism of my error values only. So here discussing about these 2 things, one is error detection mechanism as well as error correction mechanism. So that part we discuss in the next session.